So, anyways, today's the 19th. And as of today, we start factoring. There are all sorts of factoring things, techniques, styles. If you elect to go on to take Algebra 2, our first unit will be like 6 weeks, 4 weeks long, and all we do is factor. We factor squares, lookalikes, cubes, grouping, all these different things. My primary mission for you guys in Algebra 1 is to get you to factor quadratic trinomials. So at first, I guess the key here is let me tell you what it means to factor. You've been factoring FYI since like fourth grade, just not in the same way as we're going to do it. Like you guys remember back in the day when your teacher taught you about factor trees, right? I'm sure you've all made a factor tree, whether you remember it or not. At some point, your teacher probably gave you a number like 12 and said, can anyone think of a way to break down 12? And so I wouldn't write this part of the lesson down, but like if he or she gave you a 12, they would have had you draw a tree. I don't think that there's many elementary classrooms where this doesn't happen at some point. Can you guys think of a way to multiply to make 12?
Well, 6 times 2.
6 and 2. You just factored 12, right? That's called factoring. The act of breaking something down into two or more pieces that multiply to make it is literally called factoring. What you're doing is you're creating what we call factors. And then your teacher would have taught you that, oh, you can factor six more, right? Six factors into 2 times 3. And so when you write it down and you say there's a 2 times a 2 times a 3, these things right here are nouns. They're called factors. They're physical objects, nouns. The act of going from here to here is a verb called factoring. You got that? We're going to be factoring, only we're going to be factoring high school things and not numbers like 12 and 30 and stuff like that. Like that ship has sailed. Okay. So just understand when I use the word factoring, and you're going to use the word factoring and factor probably 1,000 times in the next week, that we're talking about the verb factoring means to break something down into multiplicative pieces, and the multiplicative pieces themselves are called factors. Bless you. And bless you again. So here we go. This is a quadratic trinomial, and it would have been yesterday and the day before, it would have been the answer to a math problem. I would have given you a multiplication problem of a binomial times a binomial, and I would have asked you to multiply it, and you would have maybe used the word FOIL. Maybe not. Maybe you're not into the word FOIL. Like I don't personally care for it, but on yesterday's quiz, I would have given you a set of binomials and said, hey, multiply these together, simplify your answer completely. And when you did that, the answer would have been 3x squared plus 23x plus 30. My question to you today is, can you write the math problem whose answer is 3x squared plus 23x plus 30? Do you follow the task? Do you understand your mission? Let's think common sense about this. First off, we know in the foiling process that the first thing that happens is that these two things right here multiply together by each other, correct? What would I have to put? What would I have to put in the two blanks so that when I multiplied them, whatever goes here and here, I need them to multiply to make 3x squared. What do they have to be?
1 and 3.
But there's an x squared on there too.
And 3.
Now we're talking. So if I put a 3x here and a 1x here, and let's not move on until every one of you agrees that if I wrote you a math problem where there was a 3x and an x in those exact locations, that if you began the process of multiplication, the first thing you'd get would be 3x squared. Can we agree? Good.
Mhm.
Now, what we have to do is make two different things happen now. Number one is these numbers that go in these yellow blanks now, what do they have to multiply to make? Nope.
30.
They have to multiply to make 30 because in the fourth step of the foiling process, those yellow numbers multiply by each other and they make 30. The next 30 seconds are critical. Listen carefully. I could put a lot of numbers in these blanks that multiply to make 30. You ready? I could put -2 and -15. Do those multiply to make 30? I could put 3 and 10. Does that work?
Yeah.
Heck, I could put 6 and 5. Does that work?
Yeah.
I could put 5 and 6. I could put 10 and 3. I could put 15 and 2. I could put 2 and 15. I could put 30 and 1. I could put -1 and -30. You should argue with me if you want to, but I'm claiming to you that every one of those combinations of yellow numbers, if I put them in there, would multiply to make 30, correct? However, this is where it gets interesting and tricky, is not only do I need them to multiply to make 30, but when you do the O and the I steps of the foiling, the answers have to add to make 23. So you see where it gets a little bit more complicated. So what we do, what a good factorer does, until we get really good, and you'll start feeling that way probably sometime tomorrow. But at some point, I mean, leading up to that point, it's an honest game of guess and check. You ready for this? Watch this. Use pencils because we're going to be erasing a lot. Do you all agree? Don't agree to be polite that the red ones multiply to make 3x squared.
Yep.
Do you all agree that the green ones multiply to make 30?
Yep.
Do you think this is the right answer?
No.
No. And I can prove it to you because if now I take this times this, what do I get? Correct. And if I take this times this, what do I get?
30.
And if you add those together, like get used to this, you're going to be doing it thousands of times. What do you get? And 33x is not the same as 23x. Therefore, this is a fail. But what we don't want to do is completely trash it and start over. What we want to do is say, okay, I found a couple numbers that multiply to make 30. They just weren't either the right numbers or they weren't in the right place. Moving them will matter, right? Let's try switching their locations. Let's keep them as a 3 and a 10, but let's move the 10 into the first one and the 3 into the second one. It does not change the fact that you still get your 3x squared and you still get your 30. I'm never going to let that change. I'm going to keep control of the things that I can control. But what I'm not in control of is those two little upside down purple connectors. What do the two purple connectors in the middle make?
10x.
10x. What do the two purple connectors on the outside make?
3.
9x. 3 times 3 is 9. What's 10x plus 9x?
19x.
Not 23x. So we can say now 10 and 3, you're not my guys. You're not going to work. So let's try something else. Let's jump ship.
What about 6?
Can you go ahead, Keith? What about what?
6 and 5.
Let's try 6 and 5. What order would you like to try them in?
3x plus 6, x plus 5.
I'm down. And if this doesn't work, you know what we're going to do? We're going to switch them. And the thing about factoring is I don't know what I'm saying wrong when I try decade after decade to explain this to kids. If you don't get it, it doesn't mean you're stupid. It doesn't mean you're bad. It means that's normal. Until you start to see these things, and you can only see it through practice, it takes try after try after try sometimes to find the winning combination. We don't moan about it and go, I don't get it. We get it. Sometimes we just get luckier than others. Does Keith's way work? What do the two on the inside make? What do the two on the outside make?
15x.
Add those together and you're like, God dang it, I didn't get 23x. But again, all hope is not lost because maybe if I take Keith's 6 and 5 and I switch them, what do the two on the inside make?
18.
5x. What do the two on the outside make?
18x.
And what is 5x plus 18x? Jackpot. Therefore, this thing in the purple box is the answer to this problem. We just factored our first quadratic trinomial. Let's go again. So you're going to hear me use this expression, build your shells. That's just years ago what I decided to start calling those. So build your shells. You never want to say I need help until you've at least done your due diligence and built your shells. Now, in addition to building the shells, what else could I, knowing like for sure, confidently put in? I got to make the 5x squared. And how am I going to make that happen? With a 5x and a 1x. Like that's not even up for debate. Now, this is going to be a little bit more difficult than the last one because of this little guy with the yellow arrow. That, my friends, is a negative sign. And that means that whatever numbers we put in these two blanks right here have got to multiply to make a negative. And you've known this in sixth grade. What's the rule for multiplication? How do you make a negative?
A positive and a negative.
You got to have one of each. So at this point, I don't know what order I'm going to put them in, but I use a pencil. So I'm just going to stick one of each because no matter what, they can't both be minuses or they'll make a positive. They can't both be positives or they'll make a positive. And now comes the guess and check part. Great news. How many ways are there to make 5? 1. I mean, technically 2. There's 1 times 5 and 5 times 1. So this one should not take too long. What do you want to try?
No.
What order do you want me to put them in?
1.
You want the 1 in the first one and the 5 in the second one? Is that a guess?
Yeah.
These become less guesses when you practice more. And whether Justice knows it or not, her brain might have just steered her in the right direction because she's pretty good with numbers. And she understands that if she puts this 5 over here and she power plays it up with the other 5, what do those two make?
25.
They make negative 25. And again, whether you think you're doing it on purpose or not, sometimes you see things. And what is 25 really close to? Where we put numbers is a strategy. We start to put them places where we think maybe we can get progress. And of course, let's check the inner ones as well. What do the two on the inside make? Add those together. What do you get?
Negative 24.
What did we want to get?
Negative 5x.
I believe we wanted to get negative 24x. And guess what?
Yeah.
We're done. So you can see there from those two examples that sometimes they take 5 minutes, sometimes they take 12 seconds. Piece of cake. Let's go again. This lecture, by the way, is going to wind up taking us to the end of class. So I think tomorrow we'll just start working and I don't think you're going to get any time today. So just ride with me here for the next 15-ish minutes and we're just going to keep going, man. We're going to factor together all day. Build your shells. What goes in the fronts of the shells?
X and X.
X and X, because our objective numero uno is make that. Done. That's not going anywhere. All right, someone who knows math pretty well, tell me something very interesting / maybe tricky about this problem.
We gotta make an X without making an X squared.
Tell me something about the two numbers that are going to go in those yellow blanks. What do you mean they're going to be the same?
They're getting find that one.
Yep. But don't worry about the X's. What is the answer to yellow times yellow?
5 times.
Positive 24. It's right here. Let me circle it for you. These two yellow numbers will definitively multiply to make positive 24. But here's a trick for you. And I mean a trick like a magic trick, like a quandary, a dilemma. How in the world am I supposed to come up with numbers that multiply to make positive 24, but are going to wind up adding to make a negative 10? How in the world is that even possible?
Positive 24 times 1.
You what? You can't? Say it again, Wyatt. Say it again. Yes. I was going to make you say it again. I was going to make you say it 4 more times, but I decided that'd be weird. You can do it because if you have two negative numbers, check this out. If this one's a negative and this one's a negative, what's a negative times a negative?
A positive.
But what's a negative plus a negative? A bigger negative. Mission accomplished. Getting the signs right is one of the hardest parts of my job. Getting you to understand when to use two negatives, when to use two positives, when to use one of each. And now the hunt is on. How many ways are there to make 24? I agree. There's 1 and 24. There's 24 and 1. There's 2, 12. There's 12 and 2. There's 8 and 3. There's 3 and 8. There's 4 and 6 and 6 and 4. And I think that's all. Whew.
You sounded like Dr. Seuss.
So now what do we do? You like 4 and 6? I like 4 and 6. What order do you want me to put them in there, Leander? Let's do it. Let's try this. Could we possibly be lucky enough that we got this? Skillful enough that we got this on our first try? What do we know? What do we know that red connector makes?
X squared.
What do we know this yellow connector makes? Plus 24. So you don't get any gold stars for that. That's easy. What we don't know yet is what does the pair of purples added together make? Well, let's go find out. What do the two in the middle make?
Negative 4x.
What do the two on the outside make? And what's negative 4x and negative 6x? Done. Again, you get better at this. The more you start to understand the process, you realize I'm not going to say something stupid like 1 and 24. I start to think not only about multiplying to make the number in the back, but can I also get close to the number in the middle? Nice job, LJ. Nailed it. Did you kind of know what you were doing there? Feel right? Did you just guess? Okay.
It's like it's easy, but it's also hard.
What do we do first?
Make our shells.
Build your shells. And what do we put in the beginning of our shells?
3x and x.
Good. Now I'm going to have this conversation with you. This will be the second time we have this conversation out of about 58. So here it goes. Number 2. The numbers that I put in these yellow blanks will multiply to make what? Negative 4. And this is where I just see the writing on the wall. When kids have bad basic skills and don't know rules of positives and negatives, I go, when March comes, we're dead. How do you multiply in math to make a negative? You got to have one of each. So I know going into this, before I even worry about making a 4 and all this other garbage, I know one of you is going to be a positive and one of you is going to be a negative. Because when you idiots multiply together, you better make negative. Maybe they're in the wrong order. Maybe I need the minus and then I don't care. We'll figure it out later. Now, how many ways are there to make 4? There are 3. There's 1 and 4. There's 4 and 1. And then there's 2 times 2. Which one do you think we should try?
2 times 2.
You want to do the 2 and the 2? I'm down. Let's put in a 2 and a 2. And repeatedly, you will find me not asking you to compute the red and the yellow because we're not idiots. We know the reds make 3x squared because we freaking put them there. And we know the yellows make negative 4 because we put them there. What I'm interested in is, did we land the jackpot? Do the purples work together to make what we want? What do the 2 inner purples make?
Let's do 2x.
What do the 2 outer purples make?
Negative 6.
Minus 6x. And what is 2x minus 6x?
Negative
Fail. Hey, at least we know it's not 2 and 2, so we can cross 2 and 2 off our list. What else do you want to try? Be smart. I want to put the 4 here because, think about this. What happens? Look at the only thing I have written in red up here. What happens if I put the 4 here? Who does it play with?
Because
The 3, and 4 and 3 make 12. And then I got no shot of getting back to where I wanted to get. So we start to get smart about this and say, wait a second, I'm going to neuter that 4 by putting it here. Lobotomize that 4. Call it whatever you want. I'm gonna do something to it to make it have less clout, power, influence. So I'm gonna put the 4 there and I'm gonna put the 1 there. Now what do the 2 purples in the middle make?
4x.
Correct. What do the 2 purples on the outside make? Add 4x and minus 3x, and what do you get?
X.
Did we want plus 1x?
We wanted minus 1x.
We wanted minus 1x. It's up here, right? So guess what? Switch your signs. Leave everyone right where they are. Don't touch the 3x and the 4 and the x and the 1. Take your plus and your minus and switch them to minus and plus, and you'll always get the same number with the different sign. So far, so good? I'm going to do one more, and then I'm going to up the difficulty level. Step 1,
Take your shells.
build your shells. Step 2, take the easy, the low-hanging fruit. What do we know is going to go at the front? And bless you. Let's go back and have this conversation again about signs. And I can't expect you to master this in one day, but here it goes. You have 3 possibilities. Are they both pluses? Are they both minuses? Or is there one of each? And don't guess. Look at the TV and give me a solid, intelligent answer.
There's one of each.
What are these numbers going to multiply to make? Positive 4. In mathematics, if I said, hey, Chris, do me a solid and just write me a multiplication problem with a positive answer, he's either going to give me a negative times a negative to do, or he's going to give me a positive times a positive to do, right? Because he knows if he gives me one of each, then I'm going to get a negative answer. So I know that they're either both pluses or both minuses. The question becomes, which one is it? What do you think? Of course, they're both minuses. How in the world would we ever get that minus on that 8 if we didn't use both minuses? This is where it gets tricky. The 4 tells us that they both have to be the same. The 8 steps in and says, I'll give you a little more info. Like, psst, they're both minuses. And now we begin. That's the part of factoring that I can teach you. The part that I can't is just the roll up your sleeves and go. How many ways are there to make 4? 3. You know that from last time. 4, 1, 1, 4, 2, and 2. What do you want to try? Let's try 2 and 2. We know the easy parts work. We know we made 3x squared, like, yay. And we know we made 4, like, yay. What we don't know is, did we make the magic in the middle? What do these 2 make? What do these 2 make? Add those together, what do you get? And we are done. These final 7 minutes are dedicated to the harder level. So we've achieved quite a lot, but now we need to get to like level 3. So I'm going to put a problem up here and you're going to look at it and your first thought's going to be, I don't see why this is any harder. But it's literally twice as hard. There would be absolutely no reason for you to look at that and say, I know exactly why, but I'm curious. Anyone know why it is exactly twice as hard as every other problem we just did?
You have to make 21 with the 4? No.
What's step 1? What's step 1?
Make your shell.
Make your shells. After that, what do we put in the shells?
4x and x.
Okay, like that? Okay, and you just figured out why this problem is literally twice as hard. Because when you, in the past, look back at every example we just did, 5 or 6 of them, and I guarantee you that when I said, what should we put in those blanks, there was always one answer. 3x and x, 5x and x and x, 2x and x, because there was only one way to make what we wanted to make. But this time I got some bad news, friends. It's not, it doesn't have to be 2x and 2x. It doesn't have to be 4x and 1x. Why it's twice as hard is because we're not sure. And there are now exactly twice as many places where you have to try your answers. I don't want to move on until you agree. Do you agree that 2x times 2x makes 4x squared?
Yeah.
Do you agree that 4x times 1x makes 4x squared?
Yep.
Then you should now agree, oh crap, that means I've got multiple locations now to test numbers when I want to know if they work. So what will the numbers in the yellow blanks make? Negative something, I heard you say, and that's great news that you said negative. How in mathematics do you multiply numbers and make negative answers? You got to have one of each. So right now, let's all just take a plus and a minus and stick them in there like that, knowing full well that they might be in the wrong order. We don't care. How many ways are there to make 21?
Couple, 7 and 3.
Okay, I'll write them down. So there's a 7 and a 3. There's a 3 and a 7. What else? There's a 21 and a 1 and a 1 and a 21. I don't think there's any others. So how many things do we have to try?
Like 4 things.
Nope. 8. If you're very unlucky, you're going to have to try 8. And you might say, well, okay, Mr. Ahern's having a stroke because there's only 4 things on this list, right? But you might have to try them in both templates, which is why the difficulty goes up times 2. 2 templates, double the tries. Unless you get lucky, what do you want to try first?
Minus 21.
Okay, so you want a 1 here and a 21 here. This one is going to get kicked to the curb right away because what do those purples make? Negative super butt load. Would you accept negative super butt load as an answer? That's probably not very professional. It's negative 84, which pretty much renders us not getting our way back to where we want to be. So let's go ahead and agree that that ain't going to work.
Can we try 7?
You want to swap them? Let's swap them. Let's keep the 1 and the 21 alive, but let's put the 21 where it's not so powerful like this. Maybe it'll work. I don't
It's
know.
4x. -1.
What do the inside purple ones make? What do the outside purple ones make?
4, -4x.
And what is 21 minus 4?
17.
Not what we want. So we can at least agree that 21 and 1 are not the guys that we want on the bottom template. I'm going to give you a pro tip right now. If you're still listening this far in, I'm doing my best. I hope you are too. Pro tip incoming. I can't give you much on factoring, but I can give you some guidance. You see how the numbers up here in the yellow circle are closer together than the 1 and the 21? You should always try them first.
So can we try 7 and 3?
You hear what I say? It doesn't mean it's always going to work, but you're going to find it works way more often than trying the extremes. So now Keith wants to try 7 and 3. And which template do you want? Top template or bottom template?
Let's try top template.
I'm down. Where do you want to put them?
We'll put 7 in positive 2x and then you can do.
Fair enough. Don't mind at all. Does it work? It doesn't work. The 2 in the middle make 14x. The 2 on the outside make -6, and 14 minus 6 equals 8. You can switch them around, but here's an interesting thing. Do you see how these two numbers in the yellow or the green circles are the same? Then switching them won't change the dynamic. But what we could do is let's take the 7 and 3 and let's travel downstairs to the other template. How about if we put the 4 or the 7 over here and give it power?
No.
Give it power. Give it power. And then put the 3 here. Really close. What do these two outside on the powerful make?
That makes negative 25.
They make negative 28. And what do the 2 in the middle make? And when you add those, you get, oh, we got the right number, but the wrong sign. So flip it. So switch the signs. Don't move anybody. Just switch your signs to minus and plus. I was a fool to think that would be a 20-minute lesson. So we didn't even finish my note card, but we actually did get the bulk of the learning done. So I have to shut myself up because the bell's going to ring in 30 seconds. Tomorrow, we'll probably start the day with a warm up and maybe do a couple practices. And then tomorrow's going to be a whole lot of you factoring, okay? You get the gist? All right.
I, Neil. Oh.